All right. Hi, everyone. Welcome. This session is called Easier Infrastructure and Safer Secrets. And in this session, we're going to be using a tool called Pulumi, the Azure Cloud, and a little bit of .NET Core to demonstrate how we can spin up infrastructure in a way that's pretty easy, but also in a way that's safe and a way that helps everybody not make giant mistakes. So who am I? My name's Ryan. Uh, I like to play guitar. I like to travel a bit when it's not 2020, and I like to barbecue things. I've got some of my contact details down here on the bottom if you're interested in reaching out to me. I'll show these again at the end. And in my professional role at the moment, I'm the CTO at a startup called Amphora Data. So we operate a real-time data marketplace, and we also build intelligent applications. Currently, we are a part of the UNSW 10X founder program. We've actually got some pretty cool announcements to make in about 2 weeks' time. So keep an eye on that if you're interested. And again, feel free to reach out if anything in here strikes you as interest. So what are we going to talk about? So firstly, we're going to talk about what is infrastructure automation and how to do it with Pulumi. And I'll run through a demo of Pulumi sort of halfway through this presentation. Then we're going to talk about secrets management, and some methods you can use to manage your secrets. We'll briefly touch on some parts of ASP.NET Core, which are really useful if you're using a lot of secrets and you want to write nice looking code that's easy. And then at the end, if we have time, I'll show you how you can do mostly secretless deployments. And for that, we'll use Pulumi again and GitHub Actions. So infrastructure automation. I think a lot of us here have probably done quite a lot of infrastructure automation. But when we do it, we, to my mind, want at least these 3 desirable properties for whatever tool we're using. And there might be some arguments here, and maybe there's a 4th, maybe there's some other ones, but this is just my opinion. But the 3 I think are really important: repeatability, a property called idempotency, and another one called understandability. Repeatability is pretty clear what it means. It means I can do the same thing more than once, and if I do it in different places, the same thing happens. That's really a property we want on most of our tooling. Understandability means that I know by looking at this code what it does, and I know how to change it. Again, like we want that in most of our tooling, right? The third one, idempotency, is a little bit more subtle, and I'll talk about that in a moment. But basically what it means is that when I do something multiple times, it has no extra side effects from doing something more than once. So firstly, let's look at repeatability. Generally speaking, in our first forays into cloud infrastructure, when we first start getting into it, we're going to go to a web interface like the AWS portal, the AWS console or the Azure portal, and we're going to play around with that. And we're going to create some virtual machines or some S3 buckets or something like that. Once we're comfortable with that, we start scripting, right? We start automating, and we do that because we're software engineers and we love automating things. A common place to start is just to start writing bash scripts. And this is how I started automating infrastructure. And I've just got a little sample here on how you can do some basic automation. And in this sample, I've just got a bash script that uses the Azure CLI cross-platform tool to create a resource group, a DNS zone, and an A record in that DNS zone, right? Pretty basic cloud infrastructure kind of stuff. But what happens if I run this thing more than once? And what happens is that I get an error. Okay. And the error says I'm not allowed to create more than one record of type A with the same IP address. That makes a lot of sense, right? Because in regular DNS things, you can't have more than one A record with the same IP address. But if you think about it, why did it fail at that point? If I go back to the script, I also can't have multiple resource groups of the same name, but it didn't fail there. I also can't have multiple DNS zones with the same name, but it also didn't fail there. It failed on the third one. And the reason it did that is because the first two operations were idempotent, but the third one was not. And this is a problem. So what is idempotency? Idempotency means that when we apply an operation once or apply it multiple times, it has the same effect. Often this is just called like a desired state model. And you've probably seen this in your day-to-day lives. When you multiply by 0, that's an idempotent operation, because multiplying by 0 once or 1,000 times doesn't change the answer, it's still 0. We see technologies like this every day, something like an elevator call button or a pedestrian crossing where pressing the button more than once doesn't make a difference, contrary to what I believed as a child. And if anyone's used Kubernetes, the Kubernetes API and Kubernetes controllers are another example of an idempotent system where the command, kube control apply, applying it once or applying it 10 times doesn't make a difference, hopefully. And look, the third property that's really important when we're looking at infrastructure automation is understandability, right? And a great way to do this is just to use familiar languages, right? You can write something in JavaScript and most people are going to be able to read it and understand it. And if it's not JavaScript, then it's maybe Python or C# or Go. I bet 95% of people in this virtual room could read or write at least one of these languages I have on screen. Now, you could probably write this yourself. You could probably write your own infrastructure automation tool in Python that, checked if an IP address already existed in a DNS zone and only created it if it didn't exist. But why would you bother when there's already a free tool that does it for you? And you probably guessed that tool is called Pulumi. So in a way, Pulumi is very similar to Terraform. And if anyone out there has used Terraform, then these concepts, which I'm going to talk about next, are going to feel really similar. So, why do I like Pulumi? Well, of course, it meets the criteria that I just set. Pulumi is understandable because when we read it, it's written in programming languages that we usually can understand, like Python, JavaScript, or Go. It has this property of repeatability via these concepts of projects and stacks. And I'll go into that in a moment on how they work. And it achieves idempotency in the same way that Terraform does via a desired state configuration methodology. There's some other cool reasons why you might like Pulumi. So it's all open source. The whole thing's on GitHub. It's got a consistent programming model if you're programming across multiple clouds, say GCP and AWS. Not that I necessarily recommend doing that, but if that's what you're doing, then they look the same. Then it doesn't matter where you're deploying to. It enables testing of infrastructure, which can be quite cool, especially because you can actually write unit tests on your infrastructure code if you want to. And it does have a policy as code engine that, to be honest, I'm not very familiar with. But I think if you are, programming infrastructure in large enterprise environments and large enterprise companies, then policy and compliance become really important. So what are the Pulumi concepts that you need to know if you really want to go deep and become a wizard at using it? So obviously it's a CLI. I'll briefly talk about that. There's three concepts, which are the program, the project, and the stack, which are kind of the core of what Pulumi is and how it works. And then we'll also talk about how to configure it and what the state means in Pulumi. So the main way you'll interact with Pulumi is via a command line interface, a CLI. And you can install this on whatever OS you're using. It runs on Linux, Mac OS, and Windows. And if you look at the help function, you'll see there's some common commands that it suggests you'll use most of the time. The most common command is just called Pulumi up. And what that does is it spins up your infrastructure as you've defined it in code. The other commands that it recommends you understand are Pulumi stack, which is the CLI way you interact with instances of your infrastructure. You can configure it via the CLI, and you can also destroy your infrastructure via the CLI. And this is really useful when you have modular components, which I just want to create and destroy as I like. So what's a Pulumi project? Really, it's just any directory which contains a pulumi.yaml file. And there's not too much YAML in Pulumi, so you don't get into YAML hell. But anyway, where you see this kind of a file where it's got a name, a particular runtime, which is the language we get to write our infrastructure code in, and a little description which will show up, when you look at the web interface, and sort of gives people a little idea of what the point of the infrastructure is. And this, if you want to compare it to Terraform, is similar to the root module, which is kind of the only required module when you're working in Terraform. The next thing it's important to understand is the Pulumi program. So in Pulumi, a program is literally the way you define your infrastructure. And you can write it in any of the supported languages, which there's 5. And although you are using a general purpose language, the magic of Pulumi is it turns that into a desired state. It turns it into a declarative piece of infrastructure rather than the normal method of programming you would normally be familiar with. So in this example, this is a Python example, and we're using Python to create this group object and this server object. Now, the group object maps to an AWS EC2 security group, and we've got some properties that we put on there, like the description and the protocol it supports and the port and etc. And then we also create an EC2 instance where we give it an instance type and we pass in the security group that it's a part of. Now, the way that Pulumi works, these objects that you create in Python, which is obviously an object-oriented language, mostly, they map pretty much one-to-one with the cloud resources that end up getting created. So when I instantiate an object in Pulumi, that maps to a cloud provider or any kind of provider creating some cloud resource for us. These objects, these cloud resources, these Pulumi resources, they're hierarchically organized, and you can have many children of these objects, but the root object is the stack. So a Pulumi stack is comparable in Terraform land to a Terraform workspace. So every Pulumi program must be deployed to a stack. There's no way around it. And a stack is an isolated and independently configurable instance of your program. The main reason you would have more than one stack is because you might have a production stack, so your production set of infrastructure, and a development and test set of that infrastructure. And what you want, and this is a part of the repeatability property that we were looking for, is for those stacks, those bits of infrastructure, to be similar in that I want my development environment to be like my production environment. I don't want them to drift. Otherwise, how can I be sure that when I do something in develop, it's going to work the same in production? But we can have differences between our stacks. I don't necessarily want a monster virtual machine in my development environment. I kind of don't care about latency, and there's probably not much load on my development environment. So what we can do via the Pulumi configuration tool is to make sure our stacks have different values inside them. So really common example is going to be making sure your development environment has a smaller type of virtual machine or maybe a smaller number of virtual machines than your production environment. So the last concept you should understand when you're working with Pulumi is the Pulumi state. Now, this is very similar to the Terraform state. Basically, it's a snapshot of your infrastructure at any time. And that state changes as you run Pulumi up or you edit the state manually. And Pulumi uses that state to basically do a diff between what you want your infrastructure to look like and what it looks like right now. So this is like an overview of how that happens, right? So when I write a Pulumi program, let's say I write it in JavaScript, that file runs inside the Pulumi language host. As the JavaScript file runs, the Pulumi, it's almost like a runtime, captures the objects that were created or watches the objects that were created and uses that to create the new state of our infrastructure. It then, in the engine, compares that new state to the current state and decides what changes it needs to make to ensure that the deployed state becomes like our desired state. And it does this by the 3 operations, create, update, and delete. And it can do that on any provider that you can plug in to Pulumi. So there's actually a lot of providers. You know, there's a GCP provider as well as the ones I've sort of listed up here. But, you know, so I can create something in AWS, I can update something in Azure, and I can delete something in Kubernetes. So enough theory. Let's see if we can just do a demo. Where's all my... There it is. Okay. So what I'm going to do, is I'm going to show you how you can actually get started with Pulumi. So I'm going to just create a new directory, just to put it somewhere. Let's call it NDC. And I'm going to show you the kinds of options you have when you are creating a new Pulumi program. Do that via the Pulumi new command. And you can see pretty quickly that there's a lot of options. I can code stuff for AWS, for Azure, for GCP, for Kubernetes, and I can do it in these 5 languages: C#, Go, JavaScript, or TypeScript. What I'm going to do is I'm going to create a new Azure TypeScript Pulumi program. And it's going to prompt me to give me some information so it knows how to spin up this or how to template this code for me. So I'm just going to call this project the Pulumi project, like we were discussing, NDC, the default. Again, just this default project description. Now we get to pick a stack, and you could name the stack whatever you want. You might, name it your name if you want different stacks for different developers. But again, I'm just going to keep it as the default, the dev stack. We can choose the Azure environment even, but of course, I'm just going to pick public. And lastly, we can choose the default Azure location. And because this technically is NDC Sydney, even though I'm in Melbourne, I'm going to pick Australia East. All right, and now that's going to go and create the project. And right now it's actually doing an npm install. And the reason it's doing that is because we created a TypeScript program. And the next thing it does is it downloads the plugins that we need to use. Remember how Pulumi can work with many clouds and many providers? This plugin lets Pulumi work with Azure. Cool, we're up and ready to go. So let's have a look at what this code actually looks like. Not going to full screen it like that. I'll do it like this. I'll zoom in so everyone can see that. Okay, so I can tell I'm in a Pulumi program because I've got my pulumi.yaml here. But the real meat of the matter happens here in index.ts. So in index.ts is where we're actually going to define our infrastructure. So I can see just by reading this is a property of understandability, what this program is going to do. And pretty obvious, it's going to create a resource group, and then it's going to create a storage account by newing up these objects. And down the bottom here, it's going to export the connection string for the storage account. Okay, so let's do that. I've got a short alias for Pulumi, just P in my shell, but this is just equivalent to writing Pulumi up. And now this is going to go and compare the desired state that it gets from running that program with the actual state. And of course, the actual state is empty because we only just created this stack. And it tells me what it's going to do, right? It knows that it's got to create a resource group, and it knows it's got to create a storage account. So let's do that. And now you can watch these things being created. One thing you'll notice is that I didn't have to give a lot of parameters to the creation of this resource group. If I mouse over this, you'll see from the IntelliSense that there are a bunch of options I could pass into this constructor, but the only one I need to pass is this name, at least for the Azure resource group type. That name is actually not the name of the resource group in Azure. It's actually the name of the resource in Pulumi. You look at this name here, name resource group. That's the name we defined. The actual resource group that got created is not going to be called resource group. It's going to have a kind of random name, basically. And I can probably show you that. I'll refresh that. Ooh. Oh. Got that one, but not that one. Interesting. Don't know where that went. Obviously not that subscription. Okay, but what I'm going to show you is now how when you make a change, the way Pulumi plans and knows how to make changes. So you can pass options into your resource group and enforce it to do different behavior. So one of the options you can pass is, for example, the name. Okay, and I'm just going to call this, NDC demo for my resource group. Now this is the name of the resource group that I've forced to be this property. And now if I run Pulumi up again, it's going to do the same thing it did before, compare the current state to my desired state, and then it's going to tell me via this preview feature what it has to do. And you'll see that it knows that the resource group's name has changed from this diff here. And it also knows that resource groups in Azure can't have their names changed. Resource groups are kind of stuck with the name that they're created with. So when I go to change the name, it knows that this is a destructive process for this resource group, and it needs to be deleted and then replaced. It also knows, because of the dependency tree, which it infers from this line, that the resource group for our storage account is the resource group that we created above, that the storage account also needs to be deleted and recreated. And then it also has inferred that the connection string output, which you see here, is going to be deleted and it's going to be recreated with a new connection string. The way Pulumi deals with this dependency or unknown at plan time value is it uses this type called output. So this is a string, but before the storage account is created, we don't know what the connection string is going to be, so we use this placeholder called the output. So I'm not going to do that. What I'm actually going to do instead is a destroy. Destroys are really useful because you don't want lots of infrastructure just sitting around everywhere. It does cost money. I'm sure all of us have experienced cloud bill shock. So what I'm going to do instead is I'm just going to delete this infrastructure. And in a moment, I'm going to show you a more full example of the kinds of infrastructure you might actually want to create that's a bit more complex than just a resource group with a storage account inside it. But before we do that, let's talk about secrets. Okay, so what are secrets? Secrets are the things that let you interact with your infrastructure, right? And the hard part about them is that they have to go somewhere. People need access to them, but not everybody. They need to be in the right place at the right time. So, you're going to need secrets on your developer machine when you want to prototype some new thing with some new cloud service. You'll need the connection string to that cloud resource. You'll need secrets in each of your environments, in your development, your staging, and your production environment. But you've got to make sure they're different, obviously, and you really want to make sure that your production secret doesn't end up in your development environment. It's really painful when you accidentally run a test against your production database and fill it up with something unpleasant. And the last place you're going to need your secrets are during integration tests. So how do you make sure that they get where they got to go? Diagrammatically, we can think about it like this. We've got secrets that get generated in a bunch of places. Maybe they're existing third parties that we're using. So maybe we're using SendGrid. We've got an API key that we need. Obviously, you've got your cloud credentials, which are really important. And you've also got secrets for the things that you create in the cloud. So when I create a database, I get a connection string. When I create a container registry, I get an admin password and a login URL. And I already mentioned the kind of places that we need these things. So what we really need in this situation is an abstraction layer that solves these problems, but in each of these places, it just feels like we're consuming a secret that, we don't even care where it came from. We just know that it works. Which came first, the chicken or the secret? No matter how hard you try, you can't get rid of secrets altogether. You can imagine putting all of your secrets in a box and then lock the box with a key, but now this key is just the uber secret, right? So, but there is a useful concept here which is useful, and that's the concept of identity. All of the big cloud providers have this concept of identity. And basically an identity is not attached to just a single secret that gives you access. It groups secrets together, and those secrets have roles and capabilities. So just as an example, I have an identity in Azure Active Directory, and that identity lets me interact with some Azure subscriptions, but not others. So identity is a good place to have the root secret for your infrastructure. So for the infrastructure that I've been creating, my password essentially for my Azure Active Directory account is the root secret. So what are some of the tools that we can use to enable this abstraction? So all of the three big cloud providers have their own built-in product for this that does this kind of role. In Azure, it's called Key Vault. In AWS, it's called Secrets Manager. In GCP, it's this KMS thing. And there's also a tool I want to mention here called HashiCorp Vault, which is different from the others in that it's actually a binary that you can deploy anywhere. And so again, this one's going to be really useful if you're doing cross-cloud stuff where you need to manage your secrets in one location. So of course, they all support rotation, which is pretty basic. They all have a Pulumi provider, which is really useful. So you can create these things or manage them in Pulumi. If you're using ASP.NET, which I have been using heavily, there is a slight advantage that Azure and AWS have over the others, which is they have an ASP.NET configuration integration. Now, this is just a NuGet package, so it's nothing fundamental about those products. And And actually, if you know of an ASP.NET configuration SDK for GCP or HashiCorp, I'd love to know about it. Prove this slide wrong. But that's really the only reason why you would choose one over the other. And of course, the main reason is, if you're purely on AWS, then just use AWS Secrets Manager. You don't need to go and use anything else. Just use the default. Okay, so I'm going to give you a very brief introduction to ASP.NET Core, just so you understand what we're talking about. So, blah, blah, blah. This is what it says on the website, if you go to ASP.NET Core website. But all you really need to know is, look, it's a modern web server written in C#, and you get to write C#. That's it. One thing it does use very heavily is dependency injection. And dependency injection is probably the most useful concept and pattern I think I ever learned in my career. So, a dependency is obviously an object that another object depends on. And the benefits of dependency injection is that your implementation is abstracted away from where it's used. So as the consumer, I don't need to care how it's implemented. Those implementations can then be replaced. So I can connect to either Azure SQL database or a document DB database. And as long as I'm using some kind of interface, then I don't necessarily care what the underlying database technology is. It also means that your instantiation of these kind of objects can be centralized, which is useful when you want to control the amount of connections that you might be making to a database, for example. You don't want to make 10,000 connections because you'll exhaust the pool pretty quickly. And the kind of last really useful thing that dependency injection means is that we can mock some dependencies during testing. And the ultimate result of all this is that you get loosely coupled software. And in this instance, what we care about when we're talking about infrastructure and secrets is we want to loosely couple our software from where the secrets come from. So the way you do that if you're using ASP.NET is you use the configuration system. So what that does, it injects your configurations, including your secrets at runtime, and the secret provider is abstracted from the consumer. Got a short example piece of code just to give you a sense of what this looks like. In this class, we've got a constructor that uses the iOptionsMonitor interface, which is a generic for this myOptions class. And then when the method myMethod is called, the current value of that options is now read into this variable. And what's useful is that this option could be set anywhere. This option could be set in a JSON file. It could be set in an environment variable. It could be a secret stored in Azure Key Vault. But when I'm writing this code, I don't need to worry about where it came from. So that's the end of the theory section of this presentation. What I'm going to do now is I'm going to show you a demonstration repository and code that does a lot of this stuff. And what it's going to do is it's going to take some secrets that get generated in Pulumi. It's going to store those secrets in Key Vault. And then it's going to allow certain identities, but not others, to access that Key Vault, read the secret, and then consume it. So this is all on this repository, which I can provide a link to this in the Slack channel at the end of this talk, so you guys can see what I'm talking about. But I think it's probably easier just to show you what it looks like. Very zoomed in. Okay, so in this repository, we've got our source code, and inside our source code, we've got two directories. We've got our infrastructure directory and our app directory. Now, our app directory is pretty close to a file new project ASP.NET application. It's an ASP.NET application using React. So that's why we've got this client app thing, and I can dig into client app and I can see what it is. But the kind of main interesting point of this ASP.NET application is in the program and the startup. So for those of you familiar with ASP.NET, you'll recognize this kind of entry point. And what we've done at this entry point is we've added this use key vault method. And this use key vault method is what connects our key vault into our configuration system. So what we've done is we've grabbed the key vault URI from our settings. So this is actually going to come through the environment variable. And then using the Azure Service Token Provider and the Key Vault client, we connect it all up, and this is all done in a NuGet package. You don't need to worry too much about this. And the long story short is that you get your secrets now injected into your configuration system. I'm not going to go too deeply into this code. You can see this on GitHub, and you can poke around with it. But all you need to know really is that this NuGet package means that your secrets end up where they need to be. The one kind of interesting part here is, I think, this Azure Service Token Provider. What that does is it looks for an identity that's going to be attached to the to wherever this application is running, and it's going to grab a token related to that identity, and then that's the token that it's going to use to access the key vault. And I think a good way to demonstrate how that works is to show what that looks like in the Pulumi program. So I've put everything into one big file called index.ts. But you don't need to do that because this is just a regular TypeScript program. You can break this up into multiple files. You can create your own custom resources if you want to do that. You can do most of the things you can do in JavaScript. So I've got this section here between lines 11 and 17 that's really meant to show why you might use Pulumi rather than something like Terraform. And this is kind of a silly example where we're going to check if it's a Friday, and if it is a Friday, so the day of week is 5, then we're just going to throw. We're going to say, hey, don't deploy on Friday. That's a big mistake. And the reason I'm doing this is to show you that when you're writing programs in Pulumi, you still get all of the nice magic that you get from writing regular JavaScript. Doing this kind of a comparison, this kind of control flow, would be quite difficult in Terraform because you don't get, methods like this, and you don't get to write, easy to read if statements. So let me kind of scroll through this and I'll show you what we're doing here. This is kind of a little bit too long for me really to go into all of it in depth. So if there's any questions, you can type them in the chat and I can address them. But similar to before, we're going to create a resource group. This time I'm going to give it some tags and a name. I'm going to create a key vault, right? Again, I'm just going to give it the regular SKU, and I also have to give it the tenant ID, which is something specific to the key vault object. Similar as to before, I'm going to create a storage account. And I can do quite complex stuff, right? I can create a storage container in the storage account. I can create a storage account table. You can get quite granular with what you're doing. And you can even, if you want to, import the Azure Storage SDK and start to manipulate things inside the table if you really want to. Because it's good practice, I'm going to create an application insights monitoring thing. I'm going to create a container registry, because one of the things I'm going to do is I'm going to build a Docker image of my ASP.NET application, and I'm going to push it to this container registry. And I can do that using this Pulumi tool or this sort of, not tool, class called a Docker image. And I give it the context, which is app, which I was just showing you, and I give it the registry that we want to push to. And when I run this, it's going to go and push this image up to my registry. Last couple of things we want to do is obviously we want to run this application somewhere, and I'm going to run it in an app service plan. And because I want to use containers and I want to run it that way, then I'm going to have to create a Linux container, and I have to give it this SKU. There's a bunch of options you can give it here. And then within the app service we created, we actually have to create the app service plan, sorry. We actually have to create an application, and we can do stuff like set settings, the app settings. And this is also a piece of configuration. So there is at least one secret that we'll need to, actually, no, there's no secrets here. Look at that, magic. Oh, okay, so there's the applications instrumentation key. Kind of a secret, but mostly not. But we do need to say where it's going to pull the container from. The kind of secret or the kind of key we're going to give it is this identity object. And this is like a managed identity in Azure. And it's going to use this identity to access the key vault and then get all of the other secrets that it's going to need. But we do need to say it is allowed access to key vault, and we do that by creating key vault access policies. I looped through all of the access policies. Some are static and some aren't, but the one you probably care about is the one for the application. Do you mind keeping yourself on mute? Sorry, if you're... Cool. And then, okay, once we've created all this infrastructure, all we need to do now is store the secrets that we need to use in our key vault. So I grab the connection string from my storage account, and I can store it in the key vault using this Azure Key Vault secret class. But to make it really obvious what's happening, I can also just store arbitrary strings, and I'm going to store this string here for you. So let's say hello NDC Sydney. Save that. And here we go. I'm in the trash. I can use this command to check which stack I'm a part of. I want to be in this dev stack because we also have a production stack, which I'll show you in a moment. And I'm just going to spin up my infrastructure. So what you'll see here is you'll see it'll plan the kinds of changes it needs to make. Because there are no resources, it's going to have to create everything. And all of these Pulumi resources map exactly to the code that we just saw. So you can see the Docker image that I defined. You can see the resource group. You can see the storage account plus the container and table. You can even see the access policies. So everything that is getting created, every object that I created in my Pulumi program is now being turned into literally resources in Azure. And what's really interesting, I think, is that you can do stuff that is not related to just Azure. So like I said, I'm creating a Docker image here. You can even see some of the Docker commands kind of popping up in the logs here on the right. Now, you don't have to do it this way. You can also create your infrastructure and then deploy your containers in a different way. And there are pros and cons, one way or the other. This way is simpler in the sense that I just have to run Pulumi up and everything gets spun up for me. I don't have to run a second process. But the downside here is you don't get to do any kind of promoting. You know, you can't do blue-green deployments very easily this way. You can't use the the promotion feature in App Service, for example. App Service has a way of setting slots and then promoting from that slot up into production and back again. So you can see most of these things are created except for the key vault. And then it actually even pushed my image up to the container registry. And while this is waiting to finish, look, let me show you what let me show you how you can actually put this into production. So you can see from this that as long as we can run Pulumi up with an identity that has access to our Azure subscription, then we can create the infrastructure that we care about. You can also see that I've got two stacks. One of them is my development stack, and one of them is my production stack. In development, I can change the configuration if I want to, and in production, I've actually got a slightly different configuration. In production, I've added this service principal to the kind of identities that I want to have access to the key vault, and that's because in production, this service principal is going to be running on my GitHub Actions host, and that's where we want to run our integration tests, and that's why this service principal will need access to the key vault. So when I deploy this via GitHub Actions, and I'll show you, apologies for so much YAML, you can basically grab YAML very similar to this, drop it in your repository under .github/workflows, and then when you start pushing code, it's going to spin it up for you. You can do it after you run tests. You can target different environments. So it's pretty simple. I just basically install Pulumi, I run Pulumi up, and I give it the secrets that it needs to run. So the kind of secrets it needs, obviously it needs access to Azure, which are these first three, and it also needs access to your Pulumi account. So I sort of glossed over earlier how you can install and initialize Pulumi on your machine. It's relatively simple. It's quite similar to how you would log into the Azure CLI. You can just log in via the CLI and it'll take you to a browser and do a redirect, an OIDC redirect for you. So coming back to our Pulumi up that was running here on my dev machine, you can see this has all been created, and I've got an endpoint, and this endpoint is my Azure Websites app service URL. And if I go to it, okay, cool, I can see my program is running. It looks like it's working. And I've put a little dodgy bit here where in this basic weather component page, which comes out of the box when you do a create a new project, an ASP.NET project, I've just tacked the secret onto the end there. And you can see the secret says, hello NDC Sydney, which is the same secret I set in index, hello NDC Sydney. Now, one thing to be aware of is that often these secrets are cached. So if I change this to hello Melbourne and run the same thing again, it is going to detect that there are changes, and it actually is going to change the secret in Key Vault. The challenge becomes the application caches these secrets. It caches all of its configuration. And that's a good thing because you don't want your application going back to Key Vault every single time it needs the connection string, for example. But on the other hand, what it means is that when I change the secret like I just did, and I come and refresh this page, it still says, hello NDC Sydney. And that's because it's cached. So there's two ways you can solve this problem. One is you can call a method called configuration.reload inside your application. But how are you going to know to do that? It's a bit complicated. I find the easiest way is just to force restarts of your application now and then. So, I mean, if I deploy a new container, if I make changes to the container and I deploy it, then it's going to force a restart and it's going to reload all of my secrets. And it's probably going to just naturally cycle at some point when the underlying infrastructure changes. One thing you may want to see as well is what this looks like when I deploy via actions. So that YAML I showed you earlier, that defines this GitHub workflow that runs. You can see it, all of these runs here, and you can see all of the times I broke it and it didn't work. And you can even see where I ran Pulumi up. And it did all of the stuff that you saw running on my machine. It built the container, created all of the things, and etc. And you can even see here the endpoint for my production thing, a different endpoint, different secret. And if I go here, you'll see a different secret to the one I set in my development environment. So this is really important. Make sure that when you're deploying your things and you're using your secrets, you can ensure that your secrets in your development environment and your production environment are different. Last thing I will show you is what Pulumi looks like in the web interface. I can see, I need to refresh that. Somewhere here, I'm going to have my NDC stack. And this is a useful way to keep an eye on what's going on in your infrastructure. It's kind of like a different view. So here I can see my NDC project, and I can see the stuff I've been doing recently. I can see, in the master environments, I ran this before. Oh, this is actually the one I created as a demo earlier. It's not what I wanted to show you. It's actually this one. So this is the one we were just looking at, and I can see the same endpoint, the same key vault URL, the name of the resource group, and I can even dive in and start to look at some of the resources inside. So for example, I can look at the Docker image, and I can see, exactly the Docker image that's deployed. I can see the logs that were associated with it. So this is quite a useful way to get insight into what's going on in your infrastructure, how it's getting deployed. And I tend to use this if I don't understand a problem that's occurred or something like that. Okay, so pretty much run out of time. And I know that was a big demo, but what I wanted to show you is how you can do this without exposing a lot of secrets. Like you notice I did that whole thing without exposing any connection strings or anything on this recording. So short number of sort of tips and takeaways, things that I've learned from doing a lot of Pulumi ups. The first one is, smaller stacks and more of them. One giant stack becomes quite complex. Pulumi destroy can be a lot trickier than Pulumi up, because when the infrastructure gets destroyed, it destroys it in reverse order of dependency. And if there's one thing that can't be destroyed, then anything that came before it in the dependency tree also won't be destroyed. And so you can kind of get stuck because one thing can't be deleted. One way to sometimes get around that is using a command called Pulumi refresh. And that can fix some problems, but it can also cause others. What Pulumi refresh does is it looks at your cloud infrastructure, compares it to your current state, and then will, if you want it to, update your current state to attempt to reflect the actual infrastructure. So a good example of that might be in some of those previous examples, if I had used the Azure portal to delete the storage account, then when I run Pulumi refresh, the state of my Pulumi stack will be updated to reflect the fact that that storage account had been deleted. So also use dependency injection. It's really great. I saw another talk this morning recommending dependency injection. Similarly, use configuration. And when you can, prefer identity to a secret. So if you can access a database or a container registry or a key vault or whatever via some kind of identity method rather than just a straight up connection string or a straight up secret, then you should always prefer that method because it's easier and you're less likely to expose a secret either in a Git repository or when you're sharing your screen. So thanks for coming and learning about how to create infrastructure and how to protect your secrets. I do have the Slack channel open if anyone has any questions, but I also know it's 12:30 and right before lunch. So happy to take questions. And if you don't want to ask here, you can always reach out to me by any of these contact methods I've listed below. Thanks, everyone.